This is the first assignment for the second quiz in the third trimester of Algebra 2. So this assignment or this quiz is over graphing exponential functions and logarithmic functions. And it's pretty simple. You're going to want access to some kind of graphing calculator. So there's the one online, either at the Meta Calculator site, which is on the learning plan, or Desmos, either one. And you're just going to want to be able to access the table feature and to also take a quick look at the graph itself. So we'll put this first one in here, 5 times 1/2 to the x. And it's pretty simple to get all of this. You'll have to remember how to solve exponentials and how to solve logarithms and finding the intercepts. That will be essential. So we'll start the table set up at 0 to 1. That's second window. And then go to the table. So this will be very important in the graphing and also taking a look at the graph itself. Okay, so there's the first one. Anyway, finding the x-intercept, if there is any, and there is not, this is where you let y equal 0 and you solve for x. So what's going to happen here, we know that we have to divide both sides by 5, which still produces a 0. Is that when we go to do log base 1/2 of both sides, if this is 0, there's no x-intercept. So, and you can see clearly on the graph here that it's getting close to the x-axis, but there is not one. So if ever you hit that moment where you have a 0 here, then there's no x-intercept. If there is something else, then it's going to work. So note that in the future. So find the y-intercept. This is where you let x equal 0 and you solve for y. So this actually, anything to the 0 power is 1. So our y-intercept is 5, and we can go plot that right away in our work. Now here's the deal. So I should have put the horizontal asymptote calculation first. Okay, that's going to be 0. So whatever numbers added on the end here, that's going to be the horizontal asymptote, and that's what your graph is going to be getting very close to. And now we have everything we need to answer the domain and the range. So the domain for exponential functions is always all reals. It's automatic. And for the range, it's relative to the horizontal asymptote. So it's either sitting above it or below it. So it's above the horizontal asymptote. So these two values here are the same always in this analysis right there. Always the same. And now just supply a few points here and you will have everything you need to know. So 0, 5, 1, 2.5, and then you're just going to make it get really close to 1.25, really close to the horizontal asymptote very quick. Oops, I'm a little tired today, so I'm messing up the simple stuff. And so just give me a graph that is pretty close. You just need a couple of points to go through. This is a little bit off here. No, there. So you might want to use a pencil when you do this. But just a couple of points, make it get really close to the horizontal asymptote, and that's essentially graphing exponential functions. It is not difficult, to say the least. So again, for the x-intercept, you're going to let y be 0, and in the simplifying, so we divide by 0.5. If you still have a 0 equals the bare exponential, so we would get 0 equals 2 to the x. There's not an x-intercept. You could almost do that mentally. If there's going to be one, you're going to want to show the work like I did right here. But anytime you end up with a 0, no good. Find the y-intercept. So this is where you let x be 0, and anything to the 0 power is 1. So this is going to be 0.5 times 1, which is 0.5. The domain is all reals, and the range is relative to the horizontal asymptote, which is a 0 again. But you should always check out everything. Okay, so you're going to want to take a look at the table, what the graph looks like here. Okay, so that's what it's going to look like. The range will be greater than 0, so it's always relative. You know, it's sitting above or below, so it's above the horizontal asymptote. The horizontal asymptote is 0 because that's the number that's added on the end here. So just graph a few of these. So 0.5 is the y-intercept to get, you know, an idea of how this goes for 8. So there's no special points, probably just the y-intercept and x-intercept are the special points. And then the asymptote, the horizontal asymptote is really important because that's what you got to make your graph get pretty close to when you go to do this. So definitely know where that horizontal asymptote is. Okay, so find the x-intercept. There will not be one for the same reasons I said before. When you let y be 0 and you divide by -10, you still get 0, and that won't work. Let x be 0, so 0.5 to the 0 is 1. 1 times -10 is -10. The domain is all reals. State the range, so the horizontal asymptote is 0 again, and we just need to know what does this look like relative to that. It's sitting below. Oops. It's sitting below. So we are less than 0 on that. And then you can go to your table and won't be terribly picky on graphing these. So 2, -2.5, and then just do your very best to get it very close to the asymptote. So there's no special points like a vertex. The special points are the intercepts, make it get close to the horizontal asymptote. So same thing here, the y-intercept would be -0.25, the domain all reals. State the range, so we do have 0 again. Remember, that's the number added on the end. There will be some with the numbers added on the end on the next page. So -0.25 times 4 to the x. So here's, let's take a look at it here. And it is sitting below this. So again, these two values are always the same. On every analysis, you need the horizontal asymptote to be able to answer the range. So -0.25 is really close there. Let's get some more points. 2, -4, I think that'll probably be good enough. And then just make it work. It's pretty easy. So it'll be a pretty easy quiz to do to get these graphs. Okay, so what about ones where we have some things added on the end there? So now when we let y be 0, we get this. So we would add 1 over. So now it's going to have 1, which is kind of weird for an exponential function, but sometimes you do have an x-intercept. So you got to do log base 1/3 of 1/9, which is weird, but okay. Equals x. So on that same idea as we did before in solving exponentials. You just bring the x down, then it's log base 1/3 of 1/3, which is 1. So I'm just going to use the change of base formula because that's the easiest thing alive. When you're dealing with these different bases, log of base 10 of 1/9 over log base 10 of 1/3. That's 2. So we have 2. Find the y-intercept. This is where you let x be 0, and that's 1/3 to the 1 is 1. Anything to the 0 is, I'm sorry, 1/3 to the 0 is 1. Anything to the 0 power is 1. So 9 times 1 is 9. 9 minus 1 is 8. I meant to just say 2 here. That's all we need to do. State the domain. It's always all reals. State the range. So the horizontal asymptote is -1, and now we want to see what this looks like relative to the horizontal asymptote. So you'll see it go through -1. It dips down there, goes through 2. So you're sitting above it. Remember, those values are always the same. The work for the y-intercept here, 9 times 1/3 to the 0 power minus 1. So anything to the 0 power is 1. That's the work there. So you'll know for sure how to get that. All right, so x-intercept is 2. The y-intercept is 8. And then you just got to make it work. You're getting really close to -1. You don't want to dip down below -1 when you draw it. You got to be really tight on your turn here. And that's something that I'll look for, that you get it close to, you know, the horizontal asymptote, that you get that right. And then problem 6. So x-intercept, same idea, let y be 0. And then we're going to solve. So this one will be a little bit of work, but it's just like solving an exponential that we learned in the last unit. So you get the exponential bare with a series of steps, and then you're going to do, this will be log base 2 of 1 equals x minus 2, log base 2 of 2 to the x minus 2. I'm skipping that step, but it always works out where that exponent piece comes down, and then you have a log base 2 of 2 times that. So it's whatever the exponent is, that just comes down on that side. And then you're going to add 2. So what is that? So again, I'm going to do the change of base, log of 1 divided by log of 2, oops, plus 2. And that's 2. Find the y-intercept. This is where you let the x be 0. So that's -2. 0 minus 2 up here. That's -2. So 3 times 2 to the -2 minus 3. This will be a decimal, -2.25. This is all reals, and state the range. So this is relative to the horizontal asymptote, which is through -3, because of that -3 being added on the end. So what does it look like relative to that? Is it sitting above or below? And I always say look at the graph to determine that. The x minus 2. You will have to use something that plots this. So if you need to use the online calculator, you can do it. Okay, let's just get a peek at it first. So it's sitting below. There's your horizontal asymptote through -3. I'm sorry, above it. So greater than -3 is the range. So you just have to, if it's sitting above the horizontal asymptote, that sign is greater than. If it's sitting below it, it's less than. Okay, so pretty simple. Again, You just want to make it get really close to the horizontal asymptote, and then I really don't care if you just kind of rough sketch the rest of it. And there it is. Okay, so this is essentially what your quiz is going to be like. There's a couple of questions on exponential and logarithmic data, but that's really easy to almost teach within the practice quizzes. So just follow this idea out for exponential functions. The range is related to the horizontal asymptote. So it's either greater than it or less than it. And then do this work to get the x and y intercepts. Most of the time, there's not an x-intercept because this ends up staying 0 here. And you can't do log base anything of 0. That kind of has to do with extraneous roots when you're solving. Anyway, go on to the logarithmic function assignment, and then we'll be getting into the practice quizzes pretty quick.